Hello friends. So today we are going to start a new chapter, feedback amplifiers. Feedback is very important concept in the design of electronic circuit. We cannot imagine any electronic circuit without the use of feedback. In fact, you already have encountered feedback many times. Okay, like if you remember, we used RE or emitter resistance in the case of BJT amplifier, or RS in the case of MOSFET amplifiers. Okay, these are the type of feedback we already have used. Okay, now we are going to study the feedback formally. Okay, so what is the feedback? Feedback is when some or all part of the output is fed back to the input, then it's called a feedback. Okay, so when we feedback the part of output to the input, we can feed in two ways. One way is when the part is added to the input or the part is subtracted from the input. Okay, depending upon that, we can have two types of feedback: positive feedback and negative feedback. In positive feedback, the sample part of the output is added to the input, and in negative feedback, the sampled part of the output is subtracted from the input. Okay, by default we always talk about the negative feedback, and here also we are going to see all the properties and benefits of the negative feedback and the use of the negative feedback. Okay, positive feedback also have some use, like they are used in oscillators. So here by default we will talk about the negative feedback. The negative feedback provides a lot of benefits, such as it reduces the interference, reduces the noise, reduces the distortion. Okay, increases the bandwidth. We can have better control on the input and output impedances. Okay, it reduces the sensitivity of the gain. So it has the negative feedback has n number of benefits, but it has only one drawback, that is the gain will be reduced. Okay, so this reduced gain can be seen as a cost we are paying to get all the benefits. Okay, so the first topic we will study is the general feedback structure. Let us see the structure of a feedback. So suppose this is our amplifier, which has the open loop gain A. Okay, it means A represents the gain of the amplifier without feedback. Okay, then we have a load across which the output will be taken. Now here we will sample the output and through a feedback network which has a feedback factor beta. So through this feedback network we will mix the feedback signal with the source. So after mixing, this will be the input of the amplifier. Okay, now this we are talking about negative feedback. So the feedback signal XF will be subtracted from the source signal xs, okay, and the input xi, which is the difference of xs and xf, will be given to the amplifier, which will produce the output x naught, which is sampled, and through the feedback network beta, it's given going to the input. Okay, so this is the general structure of a feedback amplifier. Okay, here x represents voltage or current. Okay, so I hope you understand the general structure. A is here, A is the open loop gain. Okay, beta is the feedback factor. Okay, so now since the open loop amplifier has a gain A, it means x naught equal to A into xi. So x naught equals to A into xi. The output x naught is fed to the load as well as to a feedback network, which produces a sample of the output. Okay, so based on this we can say xf equals to beta x naught. Okay, now xi equals to xs minus xf. Okay, you can see from here xi equals to xs minus xf. Okay, so xi equals to xs minus xf. Now we know that A which is the open loop gain, by definition it is the output by the input. Okay, this we can write as x naught by, now xi we can write as xs minus xf. Okay, or then we can write x naught equals to, so this we can multiply here, so it will be A xs minus A xf. Okay, xf is beta x naught, so we can write A xs minus A, this xf can be written as beta x naught. Okay, now we can see if we take here, from here, if I take this x naught this side, okay, and take x naught commons, we'll get 1 plus A beta. Okay, so we'll get as x naught 1 plus A beta equals to A xs. Okay, now if I take xs to the left hand side, so we'll get x naught by xs. Now see clearly here, what is x naught by xs here using this block diagram. So this is x naught output and this is xs the source input. It means x naught, see, like x naught, this x naught by xi is the gain of amplifier, but x naught by xs will be the gain of the entire feedback amplifier. Okay, let's call it AF. Okay, so this we can call it AF, means gain with feedback. A is the open loop gain of amplifier. AF is the gain with feedback or the gain of the feedback amplifier. So AF equals to x naught by xs, and we got this A upon 1 plus A beta. Okay, so this is the gain of amplifier with a negative feedback. Okay, this, if it is a positive feedback, then this plus will become minus if it is a positive feedback, but since it's a negative feedback, so it is positive here. Okay, so this application we can see many times upon this of this 1 plus A beta. 1 plus A beta is very, very important terms here. Okay, 1 plus A beta we call as the amount of feedback. Okay, 1 plus A beta is the amount of feedback. With due course of time, we will see that all the increment or decrement happens by a factor of 1 plus A beta. If something increases, it will be multiplied by 1 plus A beta. If that is decreases, it will be divided by 1 plus A beta. So 1 plus A beta is the amount of feedback. A beta is known as the loop gain. A beta is known as the loop gain. Okay, now if you see this equation carefully, what we see? We see that the gain with feedback, that is AF, is less than the gain without feedback, that is A, by a factor 1 plus A beta. Okay, so here we can see that by applying the negative feedback, gain is reduced, and this is the cost we are going to pay to get all the benefits we will see in the coming classes. Okay, so now I hope it is clear. Now see, if A beta is very, very higher than 1, okay, so from here this 1 can be neglected, then A and A will be cancelled. If you neglect this 1, so it is like A upon A beta, then A and A will be cancelled. So we can write as AF is near equal to 1 by beta. This is a very important result which tells us the significance of feedback. Here, the gain of the feedback amplifier is almost entirely depend upon the feedback network. Okay, since the feedback network usually consists of passive elements, hence a stable, accurate and predictable gain can be obtained. Okay, so it means we can see that the gain with feedback entirely depend upon the value of beta, or it is depending upon the feedback network. Usually the feedback network is passive elements, some resistors. Okay, only resistors usually will be used. Okay, so it means AF is predictable and we can design also. It can be accurate. Okay, it can be stable. So this is the feedback concept. Okay, in the next class we will study some properties of the negative feedback. Okay.